The purpose of this video is to demonstrate a technique for generating an array of random numbers with a while loop. Unlike the earlier example, this particular array of numbers will have a certain range of numbers missing from it, and so it will use a technique different from that of the for loop. We will begin as usual by creating a new virtual instrument, and then we shall toggle and look at the block diagram. We'll scoot it over there a little bit. This way you can see both parts of the block diagram and the front panel. Okay, for this one we are going to need a while loop, and the while loop is in the structures category. It's right there. You again click and drag to form a while loop of the size that you want. This is much larger than we need, and it will be sufficient. Down here in the corner we have the stop condition. When the stop condition reaches the desired state, then the loop will quit operating. So it operates while the condition is as shown. Presently has a little red stop sign. If we right click on the loop condition, we can see that the loop will stop if this condition is true, and we can toggle it to be continue if the condition is true, and we can do that either way. For this particular one, again, we will probably want to generate a random number, and so we can use, as before, our pair of dice for generating a random number. This gives you an array of numbers between 0 and 1. We want to somehow remove some of these numbers or reject the numbers if they're not the numbers that we want. So we have to consider the possibilities. If we have a range, we can either do it as an AND or an OR condition. We can say if the number is greater than the lower bound and less than the upper bound, then reject it, otherwise keep it. Or we can say if the number is less than the lower bound or greater than the upper bound, then we should keep the number. It works either way. We will try that second one at this point. So what we need are less than and greater than conditions, and we can go again to the comparison structures. We'll begin with the greater than condition, and so we will connect our pair of dice to the greater than condition, and now we want to see if our number is greater than the lower bound. And so we will create a constant here, or a control here, and we will entitle it lower bound. So there we have our lower bound condition. We probably also want the opposite condition for the upper bound, so let's see if we can find that. Again, in the comparison, we can find the less than, and we'll put it here. Again, we will put our output from our dice there, and we will then have our upper bound down here. And we will create a control, and we will call that upper bound. Okay, so now we have two logical operators there. They look kind of messy, so I'm going to select them and control U to arrange them so that they look a little nicer. There we've got our lower bound and upper bound conditions. So what do we want to do on the case that we satisfy these logical conditions? Well, we can go to our Booleans and look that we've got, this is an AND condition, this is an OR condition. Like I said, you can do it either way, so let's do the AND. If the number is greater than the lower bound and it's less than the upper bound, then we don't want to keep the number. Okay, so there we have our condition. Now, how is it that we can either keep a number or get rid of a number? Well, The thing that we will want to do here is add things into an array. So we need a case structure like we did earlier, but instead of picking the case as a list of numbers, we're going to do the true false. Again, in our case structure here, we go here, and we can put that on there. Again, we can bring our little case down, and we can go there. Okay, at this point we're going to use something called a shift register. A shift register basically takes a number or an array or whatever it is from the current iteration and saves it for use in the next iteration. So we want to create a shift register, and we will right-click and choose Add Shift Register. There's our shift register. Now what do we want to do with it? Well, if this condition is false, we want to take and add a number to our array of numbers that we have. So what we'll do is we will go to our array, build array, and we will go there. The number that we want is the random number that we had over here. So let's go ahead and click on that and see if we can get there somehow. And so we want to append that to the array, and so let's take and connect our array over there. And that was not very happy. Well, if we go here and right-click and put concatenate inputs, and then change the concatenate inputs, nothing happens. Okay, this is one of those things that you often have to worry about with LabVIEW. It's trying to convince something to behave in a certain way. Let's go ahead and get rid of the some of the bad wires here and see if we can figure out what to do with it. Okay, we could get rid of all of them, but I just want to delete that one for the moment. And we will try clicking again over here on our element, and we can see what we can do with this one here. Okay, it doesn't know what type of item it's going to be yet, and what we're trying to do is get this element here to be an array, and the other one to continue through. We'll go ahead and remove all of the bad wires at this point. And see if we can figure out some way to convince this to behave how we would like it to behave. Okay, getting rid of the bad wires again. What we would like to do is add an element to our array. And so if we start with our array, we will try passing it through here and back around like that. And so in this case, it will put things in their place. We can designate what this is to start with by creating a constant here, and we're going to do it in a couple of steps. We're going to create an array constant like this, and then we are going to add to it a numeric constant, a double precision number which has no value like that. We now have an array of length 0 that has no elements. If we connect this element to the beginning of our shift register, we now have things coming in and looking almost right. And now when we connect our single input that will go on. So what you can see here is our random number. If the thing is not in the range between the lower bound and the upper bound, it will add it to our array. What do we do if it is in the range? Well, we just pass our array through without anything happening there. So now what happens is we are growing our array each time we go through, and only when we have something in the correct range will it be appended or added onto our array. Okay, so now for the termination condition, we need to know if the array has grown to the correct size, so we will use the array size tool to measure the size of the array. And again, we want to compare it with a given size. So what we will do is we'll get our comparison structure, and as long as the array size is less than the desired size, we want the thing to keep running. So we will connect that down there. And so what is our desired array size? Well, we can again right-click here and create a control, and this one we will call array size. Okay, so now it's not looking super tidy, but it will work reasonably well. Perhaps we will control U and see how it looks. There's the logic going on in there, and so let's give this a control U and see what happens. Okay, so there we have a nice little VI that does most of what we want. At this point, it's just the sorts of things that we've done before, which are we will go and find our statistics from our mathematics. So we can go to probability and statistics, and we'll get our standard deviation and mean here. And as long as we're here, we'll go ahead and from our probability and statistics, we'll also get our RMS values here. And as before, we will connect in there, and then we will create our indicators, and you can make them fancy and show lots of sig figs as before. This time I'm just going to create all three of them quickly so that you have an idea of what's going on. Okay, and so here we are. Last thing, the lower bound, we're going to make have a default of 0.2. We're going to have the upper bound be 0.3. Oh, the array size we're going to have be 100 as the default, and the upper bound we're going to make 0.3. Okay, and so as before, we can data operations, make current value default, make current value default, and make current value default. Now if we run this VI, if we carried out lots of sigfids, you'd see that it's working just as it is desired. If we wanted, we could actually create something to display the array. So why don't we do that, as long as we're checking things here. Create indicator, and here is our array, our output array. And we will stretch that so that we can see a good part of it. And we're looking to see if there's anything at all in the range of 0.2 to 0.3, because if we did this correctly, there should not be. So let's run it and see what we get. Quick scan, I don't see anything in that range. I see things just outside of it. Again, nothing that says 0.2 of any kind. And if we run it a few more times. So there you have it, a VI that uses a while loop and a shift register in order to generate an array, and it terminates when the array reaches the size that we desire. As before, we can make this substantially larger, like 1,000,000, and it still runs essentially instantaneously. Okay,